Hello guys and welcome back to the reaction zone. In today's lesson, we're going to look at how to balance the redox equation on the board in basic medium using the Ion-Electron method. So, the first thing we have to do is to split this redox equation into two half equations. So the first one will be this, give us CrO4 2 minus, and the second one will be OCl minus to give us Cl minus. So to find which of these half equations is oxidation and which one is reduction, I can decide to find oxidation number of chlorine in this chemical species and in this one. Now, in OCl minus, oxidation number of oxygen is -2. If that of chlorine is what we are looking for, the sum will be equal to -1. So this means X will be equal to -1 plus 2, which is equal to 1. Now the oxidation number of chlorine here is equal to the charge here, which is -1. So it means that there is a decrease in the oxidation number of chlorine from 1 to -1. So what that means is that this half equation is reduction and this one is oxidation. Now that we know that, the next thing we have to do is to ensure that atoms that are neither hydrogen nor oxygen are balanced. Chromium is 1, chromium here is 1. Chlorine is 1 here, chlorine is 1 here. So atoms other than hydrogen and oxygen are balanced. So let us now balance oxygen and hydrogen for each of these half equations. Starting with the first, we have CrOH3 to give us CrO4 2 minus. There are 3 oxygen atoms here and there are 4 oxygen atoms here. That means there's an excess of 1 oxygen atom on this side. So what that means is that we're going to add 1 molecule of water to this side and then add 2 hydroxide ions to this side. This is because the rule for balancing oxygen in a redox equation that is in basic medium is that for each excess of oxygen, you add 1 molecule of water to the same side and 2 molecules of OH minus to the other side. So now let us see if hydrogen atoms are balanced. There are 5 hydrogen atoms here now, and there is 2. That creates a difference of 3 on both sides. So 5 hydrogen atoms here, 2 hydrogen atoms here. What do we do? What we have done actually should have ensured that both oxygen and hydrogen is balanced. However, we can see that hydrogen now is not yet balanced. So the next thing to do is for an excess of 1, you add 1 OH minus to the side that has excess and add 1 molecule of water to the other side. So there are 5 hydrogen atoms here. There are 2 hydrogen atoms here, meaning that there is an excess of 3 on this side. So what we're going to do is to add 3 OH minus and add 3 moles of water to this side, because the rule says if hydrogen is still unbalanced, that for an excess of 1, add 1 OH here, add 1 molecule of water here. However, there's an excess of 3, so add 3 OH here and 3 molecules of water here. So at this point, everything should be balanced. Let us check. 3 hydrogen atoms plus 2 plus 3, that is 8. 6 hydrogen atoms plus 2, that is 8. Oxygen atoms now will be 3 plus 2, that is 5 plus 3, 8. And this is 4 plus 1, 5 plus 3, 8. So we have seen that now oxygen and hydrogen atoms are balanced. Now, before I proceed, it is important to note that there are two possible steps to balance oxygen and hydrogen in basic medium. And in this particular half equation, we have used the two steps. First, we discovered that there was an excess of oxygen on this side. And for an excess of 1, we added 1 molecule of water and 2 OH minus to the other side. That was supposed to make both oxygen and hydrogen to be balanced. But that did not happen. So, if you encounter situations whereby, after doing the first step, hydrogen is still unbalanced, for that side that has excess of hydrogen atoms, you will add 1 OH minus for each excess and then add 1 molecule of water to the other side. So after adding 1 molecule of water here and 2 OH minus to this side, it's created a difference in hydrogen atoms of 3, meaning that there was an excess of hydrogen atoms on this side than this. And the excess was 3, so we have to add 3 OH minus to this side and then add 3 molecules of water to this side. So let us rewrite this particular equation. This will be CrOH3 plus 5OH minus is going to give us CrO42 minus plus 4H2. So the next thing to do at this point now is to ensure that the charges on both sides are balanced. On the left-hand side, minus 1 times 5 gives us minus 5. On the right-hand side, minus 2 times 1 gives us minus 2. Minus 2 is greater than minus 5. So what do we do to minus 2 to make it become equal to minus 5? It's simple to add 3 electrons. So this becomes our equation 1. Coming to the second half equation, the reduction half equation, we have OCl minus to give us Cl minus. There is 1 oxygen atom here, there is none here. So there is an excess of 1 oxygen atom here. So what that means is that we are going to add 1 molecule of water to this side where there is an excess, and then add 2 OH minus to the other side. So when we do this, we discover that the number of oxygen atoms here is 2, number of hydrogen atoms here is 2. Number of oxygen atoms here is 2, number of hydrogen atoms here is also 2. So in this particular case, both oxygen and hydrogen is balanced. If after doing this, hydrogen is unbalanced, then you will do what we did for equation 1, which is to ensure that for each excess of hydrogen atom, you will add 1 OH minus to the same side and add 1 molecule of water to the other side. So please don't forget that. So the next thing is to balance the charges in this case. Minus 1 times 1 is minus 1. So on the left-hand side, the charge is minus 1. And then on the right-hand side, minus 1 times 2 is minus 2. Minus 1 times 1 is minus 1. So the total charge here is minus 3. So, what do we do to minus 1 to become equal to minus 3? It's simple. That will be to add 2 electrons to this side. So, that will be plus 2e minus. And this becomes our equation 2. The next thing to do is to ensure that the electrons in both equations are the same. There are 3 electrons in equation 1, but 2 electrons in equation 2. So, what do we do? Is to multiply equation 1 by 2 and multiply equation 2 by 3. So, equation 1 by 2 is going to give 2CrOH3 plus 10 OH minus will give us 2CrO4 2 minus plus 8H2O. So this becomes our equation 1. And then equation 2 multiplied by 3 will become 3OCl minus plus 3H2O plus 6E. There's also going to be a 6E minus here. And this is plus 6E minus will give us 3Cl minus plus 6OH minus. And this is equation 2. So, we cancel out the electrons and then add the equations together. So this will become 2CrOH3. There is 6OH minus and there is 10. So 10 minus 6 will give us plus 4OH minus plus 3OCl minus. We'll subtract this from this one to get the put the equality sign. 2CrO4 2 minus 8 minus 3 will give us plus 5H2O plus 3Cl minus. So this is our final answer. So what we need to do now is to check if the atoms in the balanced redox equation on both sides are the same as well as their charges. So on the left hand side and the right hand side, the atoms we have chromium here, we also have chromium here, we have hydrogen here, we have hydrogen here, we have oxygen here, we have oxygen here, we have chlorine here, and we have chlorine here, as well as the charges. So on the left hand side, we have 2 chromium atoms, and then on the right hand side, we also have 2 chromium atoms. So we have 2 here and 2 on the right. For hydrogen, we have 6 hydrogen atoms plus 4, that is 10. So 10 hydrogen atoms here. And then on the right hand side, we have 5 times 2, that is also 10. 10 hydrogen atoms. Oxygen, we have 6 oxygen atoms plus 4, that is 10, plus 3, that is 13. So we have 13 oxygen atoms here. And then on the right, we have 2 times 4, that is 8 plus 5, that is also 13 oxygen atoms. And then for chlorine, we have 3 chlorine atoms here and 3 chlorine atoms here. So chlorine here is 3, chlorine here is also 3. So the next thing is to check if the charges on both sides are equal. Here we have the charge of minus 1 times 4, which will give us minus 4. We also have minus 1 times 3, which will give minus 3. So the net charge on the left hand side is minus 7. And then on the right hand side, minus 2 times 2 is minus 4, and minus 1 times 3 is minus 3. And the next charge here is also minus 7. So we can see from this that in the balanced redox equation, which is the final answer, that the number of atoms on the left hand side are the same as the number of atoms on the right hand side, and the net charge on the left hand side is the same as the net charge on the right hand side. So that is proof that this answer is correct. Thank you very much for watching, and see you in the next one.